Ever wondered about the biggest engineering blunders in history? Those high-profile mistakes that changed the way we approach design and construction? It's no secret that pushing the boundaries of innovation and design can sometimes lead to missteps. And while these engineering blunders can be catastrophic, they always offer us invaluable lessons. In this journey through time, we'll be looking at 8 notable engineering mistakes. From bridges that couldn't stand, walkways that gave way, to space stations that had their fair share of problems, and even a tower that leans. These incidents underscore the significance of thorough planning, understanding of materials and conditions, adherence to safety standards, and the necessity of ethical practices in engineering. Each blunder, in its own way, has shaped the field of engineering, reminding us of the gravity of the decisions made by engineers and the far-reaching impact of their work. So buckle up as we dive into these fascinating tales of engineering gone wrong. Our journey begins in 1940 with the Tacoma Narrows Bridge, or as she is more infamously known, Galloping Gertie. This bridge in Washington state collapsed in a spectacular fashion due to a phenomenon known as aeroelastic flutter. Essentially, the design of the bridge failed to take into account the impact of wind-induced vibrations. The slender deck, coupled with the suspension design, caused the bridge to sway and twist in even moderate winds. This was a stark wake-up call for engineers worldwide, and the Tacoma Narrows Bridge now serves as a textbook example of the importance of considering all environmental factors in design. Now let's set sail to the year 1628 in Sweden, where we encounter the Vasa ship. This grand 17th century warship was the pride of the Swedish Navy, but unfortunately, she sank on her maiden voyage. The ship was top-heavy, with insufficient ballast to keep her steady. As a result, she tipped over and sank as soon as she encountered a gust of wind. While this was a tragic loss, it taught engineers a valuable lesson about the importance of balance in design. The Vasa ship disaster is now a classic example of poor planning and design in naval engineering. These two incidents, while separated by centuries and continents, share a common thread: a disregard for the potentially destructive power of wind. In both cases, the wind, an environmental factor that should have been accounted for, was overlooked, leading to disastrous consequences. The lessons learned from these engineering blunders have since become cornerstones in the fields of civil and naval engineering. They underscore the importance of meticulous planning, comprehensive design, and the consideration of all possible environmental impacts. These two incidents demonstrate the critical importance of considering all environmental factors and thorough planning in engineering projects. Now let's turn our attention to the Hyatt Regency walkway collapse. It was a stark summer evening in July 1981 when the suspended walkways of the Kansas City Hyatt Regency Hotel came crashing down. The collapse was one of the deadliest structural failures in American history. A design change during the construction process had doubled the load on the connection between the fourth-floor walkway support rods and the tie rods carrying the weight of both walkways. This design alteration ultimately led to the catastrophe. The aftermath was horrifying: 114 lives lost and over 200 people injured. The repercussions echoed throughout the engineering community, leading to a reevaluation of engineering ethics and responsibility. The Hyatt Regency walkway collapse served as a grim reminder that oversight, thorough planning, and strict adherence to safety standards are paramount in engineering practice. Moving on, we journey to the realm of space exploration and the challenges encountered during the Skylab project. Skylab was America's first space station, launched into orbit in May of 1973. However, the mission was anything but smooth sailing. During the launch, the station lost one of its solar panels and a crucial heat shield, leading to a perilous situation. These initial hiccups, however, didn't deter the Skylab team. They were able to develop a solution and successfully repair the station, demonstrating resilience and ingenuity in the face of adversity. Despite the problems, Skylab served as a valuable platform for research and paved the way for future space stations like the International Space Station. The Skylab mission underscores the challenges in the design and operation of space structures. It highlights the importance of contingency planning and the need for innovative problem-solving skills in the world of engineering. These incidents underscore the necessity of rigorous safety standards and the challenges in the design and operation of space structures. Next up, we have the Citigroup Center crisis, a tale of nerve-wracking calculations and clandestine repairs, showing us that even skyscrapers can have a weak spot. Built in 1977, this 59-story tower in New York City was a marvel of architectural innovation with its 9-story stilts, allowing a church to remain on the corner of the plot. However, it wasn't long before a flaw was discovered. the bolted joints connecting the columns and trusses were not strong enough to withstand quartering winds. In essence, the building could topple over in a strong windstorm. The solution was as dramatic as the problem. Over the course of 3 months, workers welded 2-inch thick steel plates over each of the skyscraper's 200 bolted joints, all in secret and during the night to avoid public panic. The Citigroup Center crisis is now a famous case study in structural engineering and ethics, reminding us of the necessity for meticulous planning, testing, and the courage to rectify mistakes, however colossal they may be. From the potential collapse of a skyscraper, we move to the actual collapse of a nuclear reactor in Ukraine. In 1986, the Chernobyl nuclear power plant witnessed one of the most devastating nuclear accidents in history. The disaster was the result of a flawed reactor design and inadequately trained personnel. A routine safety test went horribly wrong, leading to a steam explosion and open-air graphite fire. The detrimental effects were far-reaching, both environmentally and in terms of human life. Chernobyl stands as a stark reminder of the immense responsibility that comes with managing nuclear power. It underscores the importance of comprehensive understanding of systems, rigorous safety protocols, and the need for well-trained personnel. Despite the tragic consequences, the incident led to significant changes in safety culture and regulation in the nuclear power industry. These incidents highlight the importance of ethical practices and the risks associated with nuclear power plants. Let's now delve into the Johnstown flood, an engineering catastrophe that unfolded in the late 19th century. The South Fork Dam, a massive structure holding back the waters of Lake Conemaugh, failed dramatically in 1889. This resulted in a devastating flood that washed through Johnstown, Pennsylvania, causing enormous loss of life and property. The dam's failure was a stark reminder of the critical importance of regular safety inspections and maintenance on large-scale infrastructure. The dam had been poorly maintained, and despite concerns about its stability, no substantial efforts were made to reinforce it. When heavy rains filled the lake to capacity, the dam gave way, unleashing a torrent of water onto the unsuspecting town below. This tragedy underscores how neglecting routine safety checks can lead to catastrophic outcomes. Now, let's travel across the Atlantic to Italy, where we find the Leaning Tower of Pisa, an architectural project that didn't quite go as planned. The tower began to lean during its construction in the 12th century due to an inadequate foundation built on soft soil. And yet, despite its precarious tilt, the tower has remained standing for over 8 centuries. The Leaning Tower of Pisa is more than just a tourist attraction. It's a testament to the resilience of a flawed design. The tower's unintended lean highlights the critical role of ground studies in construction. Had the soil conditions been properly assessed, the tower might stand straight today. However, the lean has also given the tower its unique charm, making it one of the most recognizable structures in the world. These incidents remind us of the importance of regular safety inspections, maintenance of large-scale infrastructure, and thorough ground studies in construction. They serve as timeless lessons in engineering, teaching us that pushing the boundaries of design and innovation must always be balanced with safety and ethics. As we look back at these engineering blunders, we're reminded that often the path to innovation is paved with mistakes. From the Galloping Gertie to the towering Citigroup Center, each of these incidents serves as a stark reminder of the importance of thorough planning and understanding of materials and conditions. The Hyatt Regency walkway collapse and the Chernobyl disaster underscore the gravity of adhering to safety standards, while the case of the Vasa ship and the Leaning Tower of Pisa highlight the consequences of poor planning and design. Ethical practices in engineering, too, come to the fore in these examples, particularly in the secret nighttime repairs of the Citigroup Center and the devastating Johnstown flood. These incidents, while unfortunate, have provided invaluable lessons, shaping the future of engineering and emphasizing the necessity for constant learning, questioning, and improvement in the field. Remember, in the world of engineering, every failure is an opportunity to learn and innovate. Until next time, keep questioning, keep learning,